In this video, you're going to learn how to graph sine and cosine graphs, and we're going to go through 10 examples together. By the end of this video, you'll be an expert at how to graph these functions. So we're going to start easy, and then we're going to gradually get more challenging. So let's start off with the basic sine and cosine graphs. How do we get the graphs? And then how do we do the transformations, like the stretching and the shrinking, the shifting, reflecting, etc. So the first thing we want to do is we want to talk about the unit circle. And you've already learned about the unit circle. If you haven't, go ahead and reference my unit circle videos. But on the unit circle, remember the sine of an angle is going to correspond to the y coordinate, okay? And the cosine is going to correspond to the x coordinate at that angle. So for example, if I want to graph the sine graph, what I'm going to do is I'm going to say, okay, at 0 degrees, okay, or you could say 0 radians, the sine value is equal to the y coordinate here, which is 0. So I'm going to put a point right here at 0. Now at 90 degrees, or pi over 2, you can see that the y coordinate, this is the value of the sine of 90 degrees, it's going to be 1. So we're going to put a point right here at 1. And then at pi, which is 180 degrees, you can see the y coordinate is 0. So we're going to have a point right here. And then at 3 pi over 2, or 270 degrees, the y coordinate you can see is -1. So we're going to be down here. Okay, and then at 2 pi, we're back to a y value of 0. So this is our basic sine graph. And what's interesting is that because we're going in a circle, it's what we call cyclic or periodic or repeating. So every time you go around, this graph is going to continue to go like that. It's also going to go this direction. That would be if you were going a negative angle. The graph would continue. But this is what we call one period. And now if we want to graph the basic cosine graph, you're going to go around the unit circle again, but you're going to be looking at the x values for each angle. So at 0 degrees or 0 radians, the cosine is equal to 1. So for cosine, we're going to start right here at the 1, or the maximum. At pi over 2, you can see the cosine, or the x coordinate, is 0. At pi, or 180 degrees, you can see the x coordinate is -1. And then at 3 pi over 2, you can see the x value is 0. And at 2 pi, you can see the cosine is 1. And so you can see this graph again has sort of this, what they call a sinusoidal. It's kind of like this S-shaped graph. And one thing you'll notice is there really isn't any difference between sine and cosine. They still have the same shape. It's just more of a matter of where they're starting. Are they starting at the midline? Like sine here starts at like this midline, whereas cosine here starts at the maximum, or this high point. So to make this a little bit easier, you're going to want to really memorize the basic shapes of the sine and the cosine graphs. So if you have to write these a few times, that's what I used to do when I was studying and learning this. Just go ahead and write it down, trace it a few times. If you ever forget, you can always go quickly back to the unit circle. I put them over here on the side. We can reference these as we go through this video. Let me erase the whiteboard. Let's get into some more challenging examples. Okay, before we dive into example number 3 and 4, I just want to mention that these sine and cosine graphs can be written in a more general way, like this y equals a sine b x minus h plus k, or cosine. And basically what you want to understand is this number that comes in front of the sine, that's multiplied by sine or multiplied by cosine, the absolute value of that quantity is what we refer to as the amplitude. It's like a vertical stretch if a is greater than 1, or a vertical shrink if a is between 0 and 1. And that's basically how high those waves are, okay? And if it's negative, what it's going to do is going to reflect it over the x-axis. It's going to make all the y values the opposite. And this b value, this group with this x here, is going to affect the period, like how long it takes to repeat, okay, or to complete one cycle. And we can use this formula here to help us find the period. It's 2 pi, which is the normal period of sine and cosine, divided by whatever this b value is. Okay, that'll give us the period. And then this h and k, the h is going to shift the graph left and right. We refer to that as a phase shift. And the k is going to shift the graph up and down. Now, an important thing to remember is whatever's grouped with the x has the opposite effect. So if this was like x minus pi, that would actually shift the graph right pi. If it was plus pi, it would actually go left pi. So it has like the opposite effect. Whereas this k value If it's plus 2, the graph goes up 2. If it's down minus 2, it goes down 2. So it has the same effect. Whatever's grouped with the x has the opposite effect. So if you can kind of remember that, and if you learn transformations, you're probably already familiar. But let's look at number 3. So notice here we've got an a value of 2. This is going to be a vertical stretch by a factor of 2. So that's how high our waves are going to be. And then our period, we're going to use this formula 2 pi divided by 4. That's our b value. So I just like to do the work off to the side here. This comes out to pi over 2 if we reduce. 2 goes into both of these. And then what I like to do is I like to divide my x-axis into 4 pieces, just like we divide this up into the 4 quadrants here, okay, as we go around that unit circle. So I take 1/4 of pi over 2, which is going to be 1/8 pi, or pi over 8. So that's like our scale. So it goes 1 pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, and then 4 pi over 8, which reduces to pi over 2. So that gives us our horizontal axis. And then the 2, that's going to be a vertical stretch by a factor of 2 in the y direction. Now again, we want to reference our basic sine graph. Okay, this graph hasn't been shifted left or right, up or down. So I'm going to start right here at the origin. I know the basic shape of my graph. So it's going to start right here at the midline. It's going to go up to 2 now, because again, we're like stretching it vertically by a factor of 2. Back to the midline, okay, down to -2, and then back to the midline. So that's going to be our sine graph. And again, if you need to do more cycles, you can keep going. 1, 2, 3, 4, do another cycle. Or same thing here, you can go this direction. Okay. Now let's take a look at number 4. This one we have y equals negative cosine of 1/2 x. Now again, if this a value is negative, that tells us the graph's going to reflect over the x-axis. So if we look at our cosine graph here, all the y values are going to be the opposite. So instead of being here at 1, I'm going to be down here at -1. Okay, so instead of this one being at -1, it's +1. So it's just going to reflect. And so let's find the period by taking 2 pi, our normal period, divided by the b value, which is 1/2. Of course, remember, when you divide by a fraction, that's like multiplying by the reciprocal. So this is really 2 pi times 2 over 1, which is 4 pi. So I go ahead and divide that up into 4 equal pieces. You can multiply by 1/4 or divide by 4. And so that gives us our scale of pi. So pi, 2 pi, 3 pi, and 4 pi. And then our amplitude is just going to be 1. That's how high these waves are, okay, from the midline, okay. But in the negative, we already talked about how that's going to reflect it. So instead of starting up here at 1, I'm going to start down here at -1, 0, 1, 0, -1, keeps repeating, right? So I like to put the little points and then I just kind of connect it. Now here's a little tip as well. Sometimes people tend to draw like straight lines through these points and the graph doesn't look super great, you know? So what you want to think about is like, this is kind of like a C, like they call it like a concave up, like a C shape up. This is kind of like a C shape down. Same thing here, like a C shape down. It's almost like a parabola sort of a shape. And then it turns to a C shape up. So it's basically like the curvature or the concavity is changing as you go. So you just kind of round it out, okay, and you'll get a little bit better looking graph. So let's take a look at some more challenging examples. Let's take a look at number 5 now. We've got y equals sine of the quantity x minus pi over 2 plus 2. First thing I like to do is figure out what the period is. And again, what we do is we focus on the number that comes to the left or just in front of that x variable. So in this case, we can see the period is 2 pi divided by b. b in this case is understood to be 1. So that's just 2 pi. So what then I like to do is I like to go ahead and label my x-axis. I want to divide it up into 4 equal pieces. I can multiply this by 1/4 or divide by 4. That's going to come out to 2 pi over 4, which reduces to pi over 2. That's our scale. So pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. Now in this case, it looks like we've got some translations happening here. Remember, when you add or subtract, that's going to shift the graph. But remember, whatever is grouped with the x has the opposite effect. So minus pi over 2 is actually going to shift the graph right pi over 2. Remember, it has the opposite effect, so plus pi over 2. The plus 2, that's going to be a vertical shift. It has the same effect. That's going to shift the graph up 2. So what I'm going to do is I'm going to go right pi over 2 up to, I'm going to put a little open circle there. I'm going to think of this as my new origin or my new starting point. Sometimes what I also like to do is draw a very light line or a dotted line and think of this as kind of like my new x-axis and my new y-axis, okay? And so I'm going to be graphing right from here, and I'm going to be graphing this graph here, just sine of x, which we're already familiar with, we've memorized, right? And I know that it starts right at this midline. The amplitude is understood to be 1 here, so I'm going to go up 1 to the maximum, then back to the midline, okay, which is this point right here, then to the minimum, which is just 1 below the midline, and then I'm going to here at 5 pi over 2, back to the midline. And so that gives me one period or one cycle of my graph. If I want to keep going, there'll be a point here, here, it continues, okay? Now let's go ahead and look at number 6. So y equals 3 times cosine of x minus 1. Again, same process. I want to find out what the period is. Again, it's that number that comes in front of the x, to the left of the x. And I use the formula, period equals 2 pi divided by b. In this case, b is 1. So our period is just going to be 2 pi, just like this last problem. So here's our period, 2 pi, divided up into 4 equal pieces. 2 pi divided by 4 is pi over 2. So that's my scale. So this is 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. But now look at what's happening here. We've got an a value of 3. That's going to make the amplitude 3. It's a vertical stretch of this cosine graph times 3. So instead of going up to 1, it's going up to 3. Instead of going to -1, it's going down to -3. We're just multiplying the y values by 3. Also, we have this -1 here. So what does the -1 do? Well, the question that you want to pay attention to is it grouped with the x or is it not grouped with the x? Well, if it was grouped with the x, there'd be parentheses around this, okay, and then it would affect the x direction. It's not grouped with the x, which means it's going to affect the y values. This is a vertical shift down 1. So what I like to do is I like to just say, okay, here's down 1, and I'm just going to think of that as my new midline, kind of like my new x-axis, maybe draw like a dashed or dotted line. It's not shifting left or right, so I'm going to think of this kind of as like my new origin or my new starting point. Again, the amplitude's 3, so I'm going to have to go up 1, 2, 3, and down from there, 1, 2, 3, okay? So now we're just going to graph our basic cosine graph, which starts at the maximum, at the high point, okay? And this has an amplitude of 3, so 1, 2, 3. It's going to start right here. It's going to go back to the midline. It's going to go to the minimum, which is 3 below that midline, back to the midline, and then back to the maximum here. Okay, so that's 3 above the midline. So if we graph it, kind of smooth it out here a little bit, that's our graph. So you can see it's definitely been stretched and it's been shifted down 1. Let's take a look at some more examples. Okay, let's look at example number 7 and number 8. So these are getting a little bit more challenging, so it's starting to get real here, right? Okay, so for number 7, we've got y equals 1/2 sine of the quantity 2x plus pi over 2 plus 1. Now, the only issue I have with this problem is, you see this number that's in front of the x, this 2? I don't like the fact that it's in parentheses. So what I'm going to do is I'm going to factor it out so it looks more like the forms we have written here, okay? It allows me to identify the phase shift a little bit more clearly. So let's go ahead and rewrite this. Now, if I factor this 2 out, remember factoring is kind of like dividing out, right? So I'm going to be dividing those by 2, right? So what this is going to look like, it's going to be y equals 1/2 sine, the 2 is in front of the parentheses now, it's just x, plus, remember when you divide by 2, that's like multiplying by the reciprocal, that's like multiplying by 1/2. So this becomes pi over 4 plus 1. Again, the nice thing about factoring is you can always check your work, you just have to distribute the 2 back into the parentheses. That gives us back 2x, this gives us 2 pi over 4, which reduces to pi over 2, which is what we had originally. So let me just erase this so it doesn't distract us from our original problem. Now, what I like to do is, like I always say, is I like to find the period first. So I say, okay, my period is 2 pi divided by b. b is this number that comes just to the left or in front of the x. So you can see that's going to be 2 pi divided by 2, which is a period of pi. Then I like to divide it into 4 equal pieces, so I can divide that by 4, or if you want, you can multiply by 1/4. So that gives us a scale of pi over 4. So pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4. Or if we go this way, negative pi over 4, negative 2 pi over 4, which is negative pi over 2. Okay, now we've got our scale. Now I like to look at, like, where is this graph being shifted? It's being shifted left pi over 4. Remember, this has the opposite effect. So you'd think plus pi over 4 would go to the right. It's actually going to go negative pi over 4 and then up 1. So negative pi over 4 up 1. I'm going to think of this as my new origin. I'm going to draw kind of like a new midline, or kind of like a new x-axis and a new y-axis. Okay, so I'm going to think of this as my starting point. And I'm going to graph the sine graph, which we've already memorized, right? But it has a vertical shrink or an amplitude of 1/2. The waves are only going to be going up 1/2 from this midline. When I think of these waves, I always think of it as like standing on the beach, right? And so you think, okay, how high are the waves? It's not like you're on a surfboard up here looking down here. You're at the middle, right? And you see how high the waves are above or below, like where the beach is. Okay, that's just kind of a way to think about it. So sine, we know, starts at the midline. It's going to go up 1/2. It's going to go back to the midline. It's going to go down 1/2 below that midline, back to the midline. Okay, and that completes one period or one cycle of our graph. It's definitely been squished or shrinked vertically, right? Okay, let's look at number 8. Now, if you're getting the hang of these, go ahead and feel free to pause the video and try these. And of course, we're going to go through them together, but you might want to test yourself. This one's got a lot going on, and I'll show you why. We've got the negative here. We've got this b value, which has a pi, which we haven't seen yet. So let's take a look at that. So first step is what? Find the period, right? So we're going to go over here to the side. Period equals 2 pi divided by our b value. Our b value is this guy right here, pi over 2. Now, when you divide by a fraction, it's the same as multiplying by the reciprocal, okay? You can see we can do some cross-reducing. 2 times 2 comes out to a period of 4. And I'm going to divide that by 4 to get our scale. So 4 divided by 4 is 1. So you can see we're counting by 1 each time. Okay, now notice that we've got an amplitude of 2. The negative is going to reflect it over the x-axis. And we're going to shift it right 3. Remember, whatever's grouped with the x has the opposite effect. So right 3 and down 2. Right 3, down 2 is going to put us right about here. So I'm going to think of this as my new origin, kind of like my new starting point, my new x-axis, my new y-axis. Okay, but I'm going to be basically graphing this graph right here, but I'm going to graph it from starting from this new shifted origin. Okay, now the sine graph we're getting real familiar with now, right? It has this, starts at the midline, but the negative is going to reflect it. So I'm going to actually go down and then up and then like that. Okay, I'm going to reflect it over the x-axis, and I'm going to be stretching it by a factor of 2. Okay, so start at the midline. Over here at 4, I'm going to go down 2, which is right about here. Back to the midline, that's 5. Okay, then 2 above the midline, that's going to be, let's see, 1, 2, be right here. Then at 7, it's going to go back to the midline, and it's going to keep repeating. So that's going to give us one period or one cycle. And again, it's going to keep going. Let's take a look at 2 more challenging examples. Okay, in example number 9, again, we're getting a little bit more challenging, and I want to show you another technique that you can use using a table and transformations when you start to get into the real deep weeds of some difficult, examples. So, but before I do that, or actually go ahead and try and do this, okay, and while you're doing that, I want to tell you a little bit about a couple things I'm excited about. One is I've got 2 video courses for sale. I'll put links in the description below. One is my Algebra 1, and the other one's my Algebra 2/college algebra video course. And I take you through a typical course with concepts that we go through together, example problems, and problems you can practice on your own as well to get some more experience. And we go through those too. And the other thing is that if you want to become more deeply involved with this channel, you can join as a channel member. So for a few dollars a month, you can be a supporter, and you get like a special member badge. So when you comment, I know that you're a member and you're part of the channel. As well as I have another level called additional videos where I've got over 100 videos on there now if you want more content. So I've got like a pre-calculus midterm and final exam review. I've got my geometry course on there. I've got an algebra readiness course. I've got my ACT and SAT math videos on there, 2 courses for those. So definitely something worth checking out if you want more information and you want to learn more with me. Check those out. But let's go through the last two examples and then we'll wrap up this video. But for number 9, we want to graph this. Now, remember, our first step is normally to find the period. But in this case, what I'm doing is I'm making a table. And I know that for cosine, these are the corresponding points. So basically, when you're at 0 radians, the cosine is 1, right? And then when you're at pi over 2 radians, the cosine is 0, -1, 0, 1. Okay, so this is just a table. But now we're going to apply transformations to get the final graph. So the way you would approach this is you'd say, okay, I'm going to work from left to right here. Okay, I'm going to say the 4 is a vertical stretch by a factor of 4. Okay, so that's going to multiply all our y values by 4. So that's going to put us at 4, 0, -4, 0, and 4. I'm going to cross out these old y values. Okay, vertical stretch. The 1/3 is going to affect the x values. Remember, whatever is grouped with the x affects the x values, but it has like the opposite effect. Remember, we talked about that earlier, and you probably learned about this when you learned about transformations. So you would think this would be like a horizontal shrink, right, by 1/3, but it's not. It's actually, you're multiplying the x values by the reciprocal by 3. It's actually a horizontal stretch by a factor of 3, which means that we're going to multiply all our x values by 3. So this is going to be 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. So let's cross out those old x values. Then we're going to pick up the graph, we're going to shift it left pi. Okay, remember, whatever's grouped with the x, opposite effect. This plus pi is actually shifting left pi. So I'm going to subtract from the x values pi. So this is going to put us at negative pi. This is going to put us at pi over 2. This is going to put us at 2 pi. This is going to put us at 7 pi over 2. And this is going to put us at 5 pi. Cross the old x values out. Okay, now the plus 2 here is going to shift the graph up 2, which is going to affect the y value. So I'm going to add 2 to all these y values, cross out the old ones. Now these are our final points. We can graph these and get our graph. Now, before we do that, I just want to mention, you're probably saying, you know, why did I do it in that order? Well, if you do the vertical shift first, like up 2, and then you stretch everything by 4, you know, you're going to get a different graph. But if it's in this form, like I'm showing you here, you can just work from left to right and you're going to get the final result, okay? Because this is a vertical stretch or shrink, this is going to be a horizontal stretch or shrink, and then you're picking up the graph, moving it left or right, up or down, okay? And that's going to be your final result. This table method is really helpful when sometimes the numbers are a little bit, you know, they're not nice multiples of pi or multiples of integers. It just gets a little bit crazy. You might want to use a table. Now, I can see that I'm going up by about pi over 2 every time. So I might want to make my scale pi over 2. Like, so I could maybe, but I could even do just maybe pi. So let's just say, and then I can do every half step. So I'll just count by pi. So this would be like pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, negative pi, right? Okay, and then it looks like the highest that y goes is 6, and the lowest it goes is -2. So I'm basically from -2 up to 6. Okay, so we've got everything. Let's plot them. So we've got negative pi, 6, pi over 2, which is at 2. Okay, that's halfway between 0 and pi. Then we have at 2 pi, we're at -2. And at 7 pi over 2, which is 3.5 pi, you're at 2. And then over here at 5 pi, you're at 6 again. So that's the maximum up here. Okay, and that's it. So that's the graph. So it's going to look something like this. Okay. Something like that. You can do it a little bit better. Okay, but basically that's the rough shape of the graph. Let's take a look at the last example, number 10. Okay, see if you can do this last example on your own, and we'll go through it together. This is definitely a more challenging problem. You can use all the skills that you've been gathering and learning through this video. You could do the table method, or you could use the other method we've been talking about earlier with just, you know, shifting that origin, that starting point, whichever one you prefer. Let's dive in. So this one here, again, we've got a lot going on. We could go ahead and find the period first, or we could use a table. Let me go ahead and show you the table method again. And what I'm going to do here is I'm going to say, okay, it's a sine graph, so I'm using the values from sine. So at 0, you're at 0. At pi over 2, you're at 1. Then you're back to 0, -1, and 0. That's where I'm getting these values for the table. Working my way from left to right, the -3, the negative is going to reflect the graph over the x-axis, and the 3 is going to stretch the graph by a factor of 3. That's your amplitude, is +3, but the negative reflects it. This is acting on the y values. So I'm going to multiply all the y values by -3, and that's going to give us 0, -3, 0, +3, and 0. Let's cross out those old y values. The pi over 8 is going to affect the x values, but remember it has the reciprocal effect, so it's going to multiply everything by 8 over pi. So I'm going to multiply all these by 8 over pi, which is going to give me 0. That's going to give me 4. That's going to give me 8. That's going to give me 12. That's going to give me 16. Now I'm going to shift the graph, not +5, but it's the opposite effect, right? It's just left 5. So I'm going to subtract 5 from all the x values, since x controls the horizontal direction left and right. And that's going to give us, let's see, these values right here. Okay, 16 minus 5, 11, right? And then the -2 is going to shift the graph down 2. So we're going to subtract 2 from all the y values. That's going to be -2, -5, -2, 1, and -2. Cross out those old y values. Now we've got our final points. We can just go ahead and graph. The only thing you might want to consider is like what is a good scale to use, like on the x and y axes. And in this case, I think I'm just going to count by, how about we count by 2s? We'll just make it, so 2, 4, 6, 8, 10, 12. Another mistake students sometimes make is the graph doesn't look right unless you try to space everything fairly evenly. If you try to like have one close together, one far apart, then your graph starts to look kind of strange. So try to be precise about it when you're doing this, just to get a nicer graph. And then over here, it looks like we can just probably count by 1. So let's see, 1, 2, -1, -2, -3, -4, -5 is the lowest. Okay, so then let's go ahead and plot these points. So -5, -2. So -5 is halfway between -4 and -6. Down 2 is going to put us right here. And then -1, -5 is going to put us down here. Okay. And then, oops, that's at -2. So -1 is going to be a little bit right here. And then over here we've got 3, -2, which is right about here. And then we have 7, 1, which is right here. And then we have 11, -2, which is right back here. Okay, so that's our graph. And it just keeps repeating. So great job if you're able to follow these 10 examples. Now the next thing you're thinking is, Mario, I need to learn about tangent and cotangent and secant and cosecant. Do you have videos on those? And I do, and I'm going to put a video right there that talks about how to graph those other graphs. So follow me over to that video right there. Let's keep practicing. I'll see you over in that video.